Hi everyone, my name is Hafizuddin and I'll be explaining about the introduction of this project. Before we go further, let's take a look at the wastewater definition. Wastewater can be considered as water that has been used in a home, in a business, or as part of industrial process. Meanwhile, wastewater treatment is the process to reduce the pollutants to safe levels and convert them to wastewater that can be recycled into the water cycle. As you can see, Figure 1 shows the common wastewater treatment process, which includes preliminary, primary, secondary, and tertiary process. Our focus for this project is the control system for the activated sludge system, which fall under the secondary treatment process. The main control parameter for the system is the concentration of dissolved oxygen (DO) in the aeration tank. This project focuses on wastewater treatment as clean water is an essential to human beings and animals. Water pollution from industrial chemicals harms our environment. Next, the impractical use of PI and PID for the dissolved oxygen concentration in activated sludge system has led us for the application of radial basis function neutral network (PID). Here are the two objectives of our project. The first one is to improve the treatment efficiency, operation cost, and system stability of activated sludge process in wastewater treatment. The second one is to review radical base function neutral network based adaptive PID (RBFNNPID) application in activated sludge process.
Hi, I'm Jing Sheng. I'm going to proceed with the process control system. In our process control system, the benchmark simulation model number 1 or the BSM1 is used. It consists of 5 reactors and a secondary settler, and we will be focusing on the reactor 5, which also serves as an aeration tank. The control variable that we have used in our system is the dissolved oxygen concentration in reactor 5, and the manipulated variable is the oxygen transfer coefficient, which can be manipulated via the air flow rate of the pump. The disturbance variables include the weather, the influent flow rate, and the influent composition. The controller that is used is the RBFNNPID algorithm, or it is also known as the radial basis function neural network (PID). The advantages of this neural network include high conversion speed, non-linear mapping ability, and self-adaptive reasoning ability. Next, let's take a look at the justification. The performance of the RBFNNPID is justified by comparing with the traditional PID. Firstly, the RBFNNPID has a good tracking performance because it is able to keep the DO concentration close to the desired set point value regardless of the changes in the set point. Next, it also has a strong anti-disturbance ability because it is able to reduce the oscillation of the DO concentration as compared to the traditional PID. Last but not least, we can also look at the evaluation indexes. Generally, the RBFNNPID achieve a smaller value for all the indexes as compared to the traditional PID, and this means that the RBFNNPID has a better performance than the traditional PID controller. Now, let's proceed with the recommendations and challenges.
Hello, my name is Hurul Aini and I will focus on challenges and recommendations. There are two important areas that must be taken into consideration, especially in terms of controlling concentration of dissolved oxygen. One of them is air supply system. Air supply system in the aeration tank consist of blowers. The blowers design are especially important in controlling the airflow speed. The blowers are equipped with variable frequency data or VFD, which is used to control the motor speed of the blower. However, controlling airspeed is very complex due to large time delays and non-linearity strength that is very high, making traditional PID controller to be insufficient in this case. Another challenges of process control in activated sludge system are the sensor. Sensors generally are not always accurate as it may be prone to noises, thus limiting the performance of a controller. Sensors in activated sludge system are also exposed to physical disturbances, in which maintenance must be regularly done to remove the film that is covering the sensor, which can also affect the measurement taken and reducing the efficiency of a controller. Several recommendations can be done to improve the traditional PID controller. One of the methods is to use fuzzy adaptive PID control, where it utilizes fuzzy mathematics to achieve non-linear intelligent control, which is something a traditional PID controller have trouble with dealing. Using the fuzzy adaptive PID control, parameters of the PID controller can be adjusted via online, and results show that the use of fuzzy adaptive PID controller shows a dynamic rapid response, small overshoot, and strong anti-jamming ability. Next, the use of multi-variable robust control, which is the design of controller that deals with uncertainty, can also be used. The use of this controller design is to achieve high performance or stability with presence of modeling errors, where it is almost the case all the time in activated sludge system in which the demand of airflow speed varies every time. This control design also has the ability to cancel measured and unmeasured disturbances. Lastly, model predictive control is a method that controls process while satisfying a set of constraints. It allows the current time slot to be enhanced while keeping future time slot into consideration. This controller also can foresee future events, in which this is very ideal in controlling DO concentration.
In conclusion, it is indeed proven that the RBFNNPID controller has a greater overall performance than the traditional PID controller based on various evaluation parameters. It is observed that the built-in algorithm RBFNNPID controller has an excellent global approximation ability of the RBF network, enables it to approximate myriad types of nonlinear function with arbitrary accuracy, where this is proven from both the tracking performance and anti-disturbing performance. Additionally, to solve the problem of poor performance of PID controller, various solutions have been proposed, which are the fuzzy control, multi-variable robust control, and the model predictive control, where it depends on the focus variable of the control system given in a particular situation. That's all for this open-ended project video presentation. Thank you for your time.